balloon in the freezer for a few minutes, and then we'll heat it up again with boiling water.
As you can see, the balloon expands significantly when heated. But why is this? Well, in 1802, Joseph Gay-Lussac published a law which explains this phenomenon. From experimentation in his laboratory, Joseph Gay-Lussac formulated his pressure-temperature law, which states that when kept at a constant volume, the pressure of a gas is directly proportional to its absolute temperature. That is, P is proportional to T. Gay-Lussac's law predicts that when a balloon is heated, the pressure of the gas contained within it increases. As a result, the balloon expands. So by Boyle's law, the pressure in the balloon decreases until it's once again equal with atmospheric pressure. This isn't strictly true, because the balloon actually exerts a pressure on the gas inside due to the fact that it's been stretched. Therefore, the pressure in the balloon is actually a bit greater than atmospheric pressure. Note that this law was arguably discovered 100 years earlier by Guillaume Amonton, and for this reason it is sometimes called Amonton's law. Gay-Lussac is arguably more well known for his law of combining volumes, which states that the ratio between the volumes of the reactant and product gases in a chemical reaction between gases can be written in terms of the ratio of whole numbers. Gay-Lussac noticed, for instance, that 2 liters of hydrogen and 1 liter of oxygen combine to form 2 liters of water vapor. Gay-Lussac's law of combining gases was published in 1808 and inspired Amadeo Avogadro to develop his law. Gay-Lussac was fascinated with the largest body of gas he could access, the Earth's atmosphere. In 1804, Gay-Lussac and Jean-Baptiste Biot flew in a hot air balloon to an altitude of more than 7 kilometers in order to investigate the distribution of moisture and temperature in the atmosphere. This was one of the earliest investigations of the properties of the atmosphere. Suppose inside a cylinder of a Stirling engine, a volume of air is heated from 25 degrees Celsius to 275 degrees Celsius. If the initial pressure of the gas in the cylinder was atmospheric pressure, approximately 101 kilopascals, what was the pressure of the gas in the cylinder once heated? Using Gay-Lussac's temperature-pressure law, we have that the initial pressure divided by the initial temperature is equal to the final pressure divided by the final temperature. Therefore, the final pressure is equal to the initial pressure multiplied by the final temperature divided by the initial temperature. Substituting in values, we get that the final pressure is equal to 190 kilopascals.
Joseph Gay-Lussac's father, Anthony Gay, was trained as a lawyer and prosecutor and worked as a judge. In the early years, Joseph Gay-Lussac was educated by the Catholic Abbey of Bordeaux, and as he grew older by the Abbot of Dumonteil, who taught him in Paris. In 1798, Gay-Lussac passed the entrance exam to École Polytechnique, a tertiary institution which was established as a result of the French Revolution. His father was imprisoned for being a noble during this time, but overcoming this, Gay-Lussac taught under Antoine François, and then independently at École des Ponts as a physics and chemistry professor for over 30 years. In addition to his gas laws, Gay-Lussac made several other great achievements in his lifetime. He co-discovered boron, characterized iodine and suggested the name iode for the element, coined the terms burette and pipette when improving the early techniques of volumetric analysis, and published Jacques Charles' work and discovered that the composition of the atmosphere is independent of altitude. Gay-Lussac achieved all of this in the midst of the French Revolution. Clearly he was able to work under pressure,